In the 1740s, a physician in London prescribed his patient a medicine and recorded the results with complete clinical confidence. The patient died. The doctor noted this in his records, adjusted the dose slightly, and prescribed it again to the next patient. That medicine, the one he kept prescribing, the one that kept killing, was the same substance sitting in tubes on the shelves of every major artist in Europe at exactly the same moment. Vermeer had used it. Turner would use it. Constable would mix it into his skies and call the color extraordinary. They called it Gamboge. They described it as the most luminous yellow in the world. And right now, the active compound inside it is in a cancer clinical trial, because at 1,000th of the dose that killed those Georgian patients, it destroys tumor cells more efficiently than standard chemotherapy. One substance, 300 years, 3 completely different identities, and almost nobody alive knows its name. Consider what that means for a moment. The same jar on an 18th century apothecary's shelf and a painter's shelf. 2 entirely different professions. 2 entirely different intentions. One is trying to create beauty. One is trying to cure disease. Neither knows the other is using the same thing, and neither understands what that thing actually is. And the scale of the contradiction is not small. At 200 milligrams, less than the weight of a paperclip, Gamboge is a purgative. At 500 milligrams, it causes internal inflammation severe enough to hospitalize a patient. The line between medicine and poison is thinner than a quarter of a gram. Georgian physicians, working without standardized measurements, crossed that line routinely. Meanwhile, the artists they lived alongside were handling the same compound every day, grinding it into powder, mixing it with water, breathing the dust, with zero protective equipment and zero understanding of what it could do to a human body. The pigment that made paintings beautiful was, simultaneously, the most dangerous substance in the apothecary's cabinet. And it came from a place that almost no one in Europe had ever seen. By the end of this video you will know 3 things. The tree that produces Gamboge only releases its resin when it is wounded, and it takes 5 years of slow, continuous bleeding to fill a single bamboo cane. Every tube of Gamboge on Vermeer's shelf represented half a decade of a tree's suffering. The compound inside Gamboge, gambogic acid, is currently in phase 2 human cancer trials. A 2019 paper in Cancer Letters confirmed it destroys cancer cells at concentrations 200 times lower than standard chemotherapy drugs. The Georgian doctors who killed their patients with Gamboge were not wrong that it had medicinal power. They were simply using 1,000 times too much of it. 300 years of getting the dose wrong. 1 generation of researchers getting it right. Let's go back to where this started. Scene 4 Beat 3. The Invisible Truth. 2:20. 4:00. Deep in the forests of Cambodia, Vietnam, and southern Thailand, there grows a tree called Garcinia Hanburyi. It does not look significant. Medium height. Waxy, dark green leaves. Small yellow-orange fruit the size of a plum. If you walked past it in the forest, you would not stop, but cut into its bark, score a spiral groove around the trunk, and something happens that you would not expect from a tree. It bleeds. A thick, luminous sap begins to ooze from the wound. Not red, not brown. A yellow so vivid and so pure that it almost does not look real. Somewhere between sunlight and gold, like something that should not exist in nature. The harvesters, who have known this tree for at least 1,000 years, place a hollow bamboo cane at the base of the wound and walk away. They come back in 5 years. Because the tree bleeds slowly, the resin hardens inside the bamboo into a dense, waxy cylinder over half a decade of continuous seeping. That cylinder, ground to powder and dissolved in water, produces the color that European masters would call Gamboge, and spend fortunes to import, without ever knowing what tree it came from, or what the tree was actually doing when it bled. The tree was not making art. It was making a weapon. Garcinia Hanburyi does not grow in Europe. It does not grow in the Americas or in Africa. It is native to a specific band of tropical Southeast Asia, Cambodia, Thailand, Vietnam, and parts of southern China, where the humidity, soil acidity, and temperature range create the precise conditions the tree requires. The Dutch East India Company first received a shipment of it in 1640 from traders in the port of Batavia, present-day Jakarta. The canes of hardened resin arrived without explanation. The company's records note only that the substance produced a yellow of unusual intensity, and that no one aboard the ship could say with certainty what plant it came from or how it was made. They named it after Gamboge, the Latin name for Cambodia, and began selling it to artists across Europe at a significant premium. For the next 100 years, European painters used Gamboge without a clear understanding of its origin. The tree was not documented in Western botanical literature until 1852, when botanist Daniel Hanburyi, after whom Hanburyi is named, formally classified it and described the harvest method. By then, Gamboge had been in continuous use in European painting for over 2 centuries. Vermeer had been dead for 180 years. Turner was painting with it right now, and the physicians were still prescribing it. Here is what the tree was actually doing, and why the science of it matters more than the history. Garcinia Hanburyi produces gambogic acid not for human beings, but for survival. It is a defense compound synthesized when the tree detects attack from insects, fungi, or intense UV radiation. The molecule is the tree's immune response made physical. The biochemical pathway that builds it, called the polypeptide pathway, is the same process that produces many of the world's most powerful antibiotics. The molecule is specifically engineered, at a structural level, to disrupt cellular replication in the organisms attacking the tree. In an insect larva, gambogic acid triggers programmed cell death. In a fungal colony, it collapses the membranes. The tree does not fight its attackers. It instructs their cells to destroy themselves. You see, of course, exactly where this is going. A molecule designed to trigger cell death in invading organisms. A molecule with extreme potency at minute concentrations. A molecule that the human body absorbs rapidly and that crosses cell membranes with unusual efficiency. For a tumor cell, which is, at its core, a human cell that has lost the ability to stop replicating, gambogic acid is a precisely targeted instruction to do the one thing the tumor has forgotten how to do. Stop. Here is where it gets complicated. The physicians who killed their patients were not incompetent by the standards of their time. The Georgian Pharmacopoeia, the official list of approved medicines, listed Gamboge as a legitimate therapeutic agent. It was prescribed by licensed physicians in licensed hospitals to real patients who trusted them. The problem was not bad intentions. The problem was no mechanism. Without any understanding of how gambogic acid worked at a molecular level, physicians had no basis for calculating a safe dose. They knew it caused purging at low doses. They assumed more would purge more effectively. They were applying a simple logic to a compound whose power operated on a scale they had no tools to measure. At the same moment, in studios a few streets away, painters were mixing gamboge with gum arabic and water every day, breathing the powder, touching it with bare fingers, occasionally ingesting trace amounts accidentally. And they were not dying, because the dose in a painter's mixture, spread thin across a watercolor wash, was orders of magnitude below the threshold that makes it dangerous. The irony is precise. The artists using it decoratively were safer than the doctors using it medicinally. The profession dedicated to healing was the one causing harm. The profession dedicated to beauty had accidentally stumbled into the correct dosage range. Most people who encounter the word gamboge, if they encounter it at all, assume it is simply a historical curiosity. An old pigment, replaced long ago by safer synthetic alternatives, now relevant only to art conservators and museum restorers. That assumption does not survive 2019. In that year, a paper published in Cancer Letters by researchers at the Chinese Academy of Medical Sciences reported the results of Phase 1 clinical trials testing gambogic acid in human patients with advanced solid tumors. The compound had passed safety trials. It was moving to Phase 2 testing whether it actually worked against cancer in living human beings. Think about what that means for the timeline. The tree in Cambodia has been producing this compound for millions of years. The harvesters have been collecting it for at least 1,000. The artists have been painting with it for 350. The doctors accidentally killed people with it for 2 centuries. And the researchers who might actually unlock what it can do have been working on it for 20 years. The historical curiosity is currently in a human clinical trial. The molecule the Georgian doctors got catastrophically wrong is the same molecule a cancer researcher in Beijing is calibrating to the microgram. The next time you stand in front of a painting in a gallery, any gallery with Dutch Golden Age work, English watercolors, or Japanese woodblock prints, find the yellow. The warm, almost glowing yellow in the curtain folds, in the light coming through the window, in the distant fields, in the morning sky. There is a measurable probability that what you are looking at is gambogic acid, the same molecule that a tree in Cambodia synthesized to kill the insects eating its bark, the same molecule that a London physician ground into powder and prescribed to a patient who did not survive, the same molecule that is, at this precise moment in time, being tested in a clinical trial against human cancer. It never stopped being powerful. The tree never changed what it made. We spent 300 years arguing about what it was for.